Do you feel the vibes? So in the last two over there, we simplified a little bit, but there is still room for more. So that's what we're going to do, right? So example 5, A and B. Okay. Okay. So here what we got was cotangent and cosine, right? Now, more often than not, we are going to reduce these or change them so that they are all written in terms of either sine or cosine, right? So with that said, then, in this case, the cotangent can be written as cosine theta over sine theta. And then this is times cosine theta. And we know that's over 1. So this will be cosine squared theta over sine theta. Okay? So, always look for what is being asked of you. So with these things that we're doing right now, in real life, this is never like just the problem, right? The problem is never just this. This that we're doing here is always like one step out of like a half a page of like other stuff. And so with that context, you know exactly like in what version to write everything in, right? But here we're going to do just everything that we possibly can. All right, so let's do the same thing here. Negative secant is negative 1 over cosine theta. Sine is as simple as it can be. So is cosine. But now you can see that the cosine and the cosine reduce. So this will just be negative sine theta. Okay? Okay.
Negative sine theta.
Okay.
Oh.
So, right. Okay, so let's do more of these. Can you make sure they're all, oh my goodness. Make sure they're all turned off. Okay. So here we go. Let's talk about simplifying expressions, right? Simplifying expressions are basically applying identities to make things a little bit simpler, right? Now, there are some tips that we can do here. There are a couple of things we can do here to simplify functions. One thing is, like tip, right, is to write functions in terms of sine and cosine, just like we were doing just now. Another thing is factor out a common term, right? Another one is apply a Pythagorean identity. Remember the 3 Pythagorean identities. The way you know to apply a Pythagorean identity is if there is a trig function squared with a plus or a minus 1. So 1 plus sine squared, tangent squared minus 1, and so on. Okay? Or you can apply other identities. The most important thing here is none of this is clear cut, that you have to do this first, then this second, then this third. And you can really do these in any order. Okay? So this says write so that, it's one trigonometric function. Okay, so let's see. Or we're just going to simplify it as much as we can. So sine of theta, cosecant, and so on. So what we're going to do is the following. Sine of theta, not much can be done with that. Times cosecant of theta is 1 over sine of theta. Cotangent of theta is cosine theta over sine theta. Remember to always put the thetas. Okay, next, let's simplify where we can. The sine and the sine will reduce to 1 over cosine theta over sine theta. So if you have 1 over something, what's another word for that? Reciprocal. So this is just sine theta over cosine theta. Okay? Or you can say this is tangent of theta, but that's it, nothing else. All right? I said or, so either or will work. Either or. Okay, so here we go. This one has parentheses, I believe. All right, so let's do this. Sine theta times, okay, the cosecant can be written as 1 over sine theta minus sine theta. Okay? Now, let's distribute. When I distribute here, I get 1. Right? Sine times 1 over sine. Minus sine of theta times sine of theta is what? Sine square theta. Remember, it's not sine of theta squared. That's a different thing. Sine square theta. Now, this is where this third thing comes in. Apply a Pythagorean identity when you have a trig function squared plus or minus 1 with it. So this is the one with the sine squared. When you look on that first page, right, that's that first Pythagorean identity. So let's just write that here. This is the identity that includes the things we have here. Now, this identity is like any other equation. It is not a rigid thing. We can move things around as we want in these. So what I have in my problem is 1 minus sine squared. Somehow I need to make this look like that. But I can do that by doing what? Subtract sine squared theta. So I get here cosine squared theta is equal to 1 minus sine squared theta. So now if I come here, this whole thing is actually just equal to cosine squared theta. And that's how I simplify this, right? So how do you know? You just have to train your eye to see that if you have a 1 plus or minus a trig function squared, that's what we're going to do. Okay, let's do this one. Parentheses here. Okay, so here we go. So secant is 1 over cosine. Tangent is sine over cosine. Now, in short, we say sine over cosine, and maybe like we kind of let the theta slip, but don't let it slip when you're writing. Okay, here I have 1, and then there was a plus or minus, and there was a trig function squared, right? Cosine squared. So that's going to be, this is where the cosine squared shows up. Same identity as before. This time, though, I want it to look like 1 minus cosine squared theta. So what am I going to subtract from both sides? Cosine squared theta. So sine squared theta is 1 minus cosine squared theta. That means this whole thing is sine squared theta. Okay, now go slow. We're not going to do everything at the same time. Let's look at the fraction here. This is one complex fraction, right? But I can simplify the cosine with the cosine. So now in that purple fraction, what do I have left in my numerator? 1 in the denominator sine theta times sine squared theta. 1 goes with 1 sine theta. Okay?
Oh,
Okay, so that's this. 1 minus cosine squared is sine squared. Then we just copied it over. Okay. All right. Okay, let's take a look at this one. What do you think? What? Huh? Okay. So here, I know I said whenever you see a trig function squared plus or minus 1, that's a Pythagorean identity. But this is 2 trig functions squared plus or there is no such thing, right? You can't do that yet. It only has to be one thing squared, right? So here, why don't we just write this as sine squared theta over cosine squared theta. Let's write this as 1 over sine squared theta minus 1. Let's write this as 1 over cosine squared theta. So, let's see. Sine squared, sine squared. So what I have now is 1 over cosine squared theta minus 1. 1 over cosine squared theta. Do you see how all I did was cancel one sine and sine, and I rewrote the whole thing, right? So when you see me doing that, right, do you think, oh my gosh, like she's so slow, she needs to write things over and over again, right? No, this is how I keep my brain focused and organized. Because when you've got markings here, there is no way to keep track of things. But now I can see exactly what I have. Look, I've aligned everything, right? So I know what this looks like. So again, I've got a main fraction with fractions on top, fractions on the bottom. This is a mega complex fraction. I need to simplify this. So to simplify, we can multiply top and bottom by the common denominator across all the denominators. How many denominators exist in this? So I have the cosine squared on top, 1, and another cosine squared. The common denominator is cosine squared theta. So let me do this and I'll take questions. I'm going to multiply this by cosine squared, multiply this by cosine squared. This is like what we did in chapter 8. Distribute, distribute. Okay. First term, when I distribute, what does it give me? 1. Second term, cosine squared theta. What do I have on the bottom? What does all this give me? 1. Okay, what now? What do you think? Wait, Taylor, yeah. Right, so now I have 1 and then a plus or minus and then a trig function squared, right? And look, I actually did this before in this previous problem. We said this was equal to sine squared theta. So this will just be sine squared theta over 1, which is nothing. Okay, now is a good time for questions. Wait, I think she had raised her hand first. Go. From here and here? Because this is being added to or subtracted from something else. So you can't do that. Okay? Yeah.
Why isn't it just negative cosine squared theta?
Because the one and the same reason, you can't cancel them out. Okay? So this whole thing is one unit. The whole thing can cancel with an identical thing on the bottom. All right. Okay. Let's take a breath. Let's do one more. Okay. So here we go. What do you think? What strategy? Right, rewrite as sine or cosine. So this is going to be 1 over cosine. That's really a safe bet. Sine squared theta over cosine squared theta. Oh, you know what? No. Take it back. I mean, look, we could have definitely done it that way. It would have taken a lot more nasty math. Fun, but let's do it more efficiently. Because look, okay, we did this a couple times. We never did this yet, right? I wonder if that will apply here, right? So if I have like 3y squared minus y, can I factor anything out? I can factor out a y, and what do I get? 3y minus 1. So here, is there a common term that I can factor out? A secant, right? If I factor out a secant, what do I have left from the first thing? Tangent squared theta plus 1. So, secant, what's secant? 1 over cosine. Okay, but what about here? Now I have trig function squared plus or minus 1. Let's go to the identities. Oh my God, that exists as it is. The whole thing is just equal to secant squared theta. Secant squared theta okay, so what is that? 1 over cosine squared theta. This is 1 over cosine cubed theta. Okay? So look, this was 1 over secant squared, we know is 1 over cosine squared. Multiply the numerator, multiply the denominator is equal to this. Now, or you can also leave it as secant cubed theta. Either will work. Okay? Okay. So I have 1 over cosine secant squared. Secant is 1 over cosine. So I have 1 over cosine squared. Now, multiply numerators, multiply denominators. That's what it gives me. Okay, let's do this next one. Okay, so sine of x, cosine x over sine of x, 1 over cosine x. So if it's in theta, leave it in theta. If it's in x, leave it in x. Now, oh my gosh, look at this. Sines, cosine, just 1. Okay. So now, we basically tried, a couple of different things. Of the things we tried so far, what would you do? Which one of those, don't call anything out yet. I'm just going to give you guys a minute to think, and I'm going to call on somebody. Which one of those would we try for this one? And you don't have to be raising your hand for me to call on you, so let's all think about this for a minute. So we can rewrite, we can factor out, we can apply a Pythagorean identity. So, okay, Ari, what do you think? Which one of those would you do on this one? Let's factor out. What would you factor out? A cosine. So if I factor out a cosine, okay, Shelby, what do I get? Correct. Okay. So Ness, does that remind you of anything now? What would you do now? No, come on, tell me. Which of the 3 that we did would you apply to this? So would it be writing as sine or cosine? Would it be factoring something out? Or would it be using a Pythagorean identity?
Oh,
The Pythagorean identity, right? But we already did 1 minus sine squared somewhere. What did we get for it? Cosine squared theta. Okay, so this will be cosine squared x. Cubed, sorry, cosine cubed x, thank you. All right, so let's rewrite this one. So tangent will be just sine theta over cosine theta. Cosecant will be 1 over sine of theta. Secant will be 1 over cosine of theta. Sine and sine will reduce. I get 1 over cosine of theta. 1 over cosine of theta. How much is all that? 1. Okay, now, before I take any more questions, on this page we have E, F, G, H, 4 of them. I'm going to give you about 6 minutes to do all 4 of these. We're going to do them independently without sharing answers or solutions with anybody, right? And really, A, look at the tips I've given you in that box. B, compare the problem you have with another one that we did that is similar, all right? So 6 minutes. On your mark, get set, go.